Imagine this. In the middle of a desert where there was nothing just yesterday, an incredible structure suddenly appears. A tower nearly 830 meters tall, sparkling with metallic rings, with a circular tunnel at its base. People watch in amazement. Some think, this is a new architectural wonder, but no. It's a giant MRI. Yes, you heard that right. A magnetic resonance imaging scanner, but not in a hospital or a laboratory. It's the size of the Burj Khalifa, the tallest building on Earth. Now the main question, what would happen if it were turned on? What forces would we unleash? What consequences await everything around it? What would happen to technology, biology, the weather, and possibly reality itself? What is an MRI? To understand the scale of the catastrophe, we need a little science first. An MRI is a device that generates a powerful magnetic field directed into the human body. Using radio waves, it causes hydrogen atoms to resonate, and the resulting signals are converted into detailed images of internal organs. No pain, no radiation, just pure physics. In regular machines, the magnetic field strength ranges from 1.5 to 3 Tesla, but now we are imagining something far larger. Suppose we create a device using the same principles, but 1,000 times bigger. 828 meters tall, with a scanning ring 150 meters in diameter. Its weight, tens of millions of tons. The volume of the coils is comparable to a football stadium. Power supply, tens of gigawatts. The question, could such a machine be turned on? Theoretically, yes. Practically, no one would dare. But let's imagine a super magnet. If a regular MRI operates at 1 to 3 Tesla, our giant could generate hundreds or even thousands of Tesla. For comparison, the Earth's magnetic field is about 0.0005 Tesla. The most powerful laboratory magnet in history reached around 100 Tesla. Our hypothetical MRI, over 1,000 Tesla. Such a field literally distorts the physics of the surrounding space. Possible consequences: metal objects would be pulled with bullet-like speed. Currents would be induced in wiring in humans. Electronics would fail, brain activity would be disrupted, and space itself would begin to vibrate. What would happen to a person? Even at 10 Tesla, humans experience dizziness, loss of balance, metallic taste, and visual disturbances. Now, multiply that by 100. Blood-containing iron would start moving abnormally in the vessels. People with implants would be at serious risk. Nerve impulses could be distorted. Short-term memory and reflexes might fail. A person near such an MRI would not be a patient. They would be a victim, the metallic threat. Any metal would be attracted, heated, and turned into a weapon. Tools, furniture, bicycles, cars, everything would fly inward. Reinforcements in buildings would start to shake. Even shadows from wires could start to oscillate, like in a horror movie. Energy hunger. Such a device would consume 5 to 10 gigawatts, equivalent to the entire electricity consumption of Greece in an hour. If suddenly turned off, the coils would generate an electromagnetic pulse comparable to a nuclear one. Everything within a 10-kilometer radius would lose power, burn out, or glitch. Cities would freeze. Atmospheric effects. The powerful magnetic field interacts with the ionosphere. Aurorae could appear, geomagnetic storms might occur, airplane navigation could fail, and birds would lose orientation. Satellites in orbit would be deflected. This is not just a medical device. It is a tool on a planetary scale. The edge of science fiction, a field of thousands of Tesla, is already at the edge of quantum exotica. Effects such as space distortion, atomic bond modification, vacuum fluctuations, and even microportals could appear. Nobody knows what would happen. This is a zone where physics becomes unpredictable. Scanning the planet. Hypothetically, such an MRI could scan the Earth completely, locate ancient cities underground, detect oil deposits, caves, water, and map tectonic faults in real time. Could it become a window into other worlds? Theoretically, yes. Practically, we are not ready. Conclusion. If you were to turn on an MRI the size of a skyscraper, the surrounding space would be physically deformed. People would suffer from invisible forces. Metal would become deadly. Electronics would vanish. The atmosphere would change, and fundamental laws could tremble. The good news? We cannot build such a device yet. The bad news? If we ever do, we may never be the same. Such technology is not just a machine. It is a mirror reflecting the boundary between knowledge and madness. The bottom line, in the foreseeable future, hardly anyone will seriously attempt to build such a machine. Its scale, risks, cost, and potential for destruction are not something humanity is ready to toy with. But we have shown you what could happen. What could happen to cities, to people, to the planet if someone presses that button. This is not a prediction. It is a warning. If, one day, a certain madman decides to build and activate an MRI as tall as a skyscraper, let them at least know what they're getting into, because this button could trigger not just a magnetic field, but a chain of events that can no longer be stopped.